that we can then just require one click to update your status. Now, sites are, most sites implement cross-site request forwarding protection, but quite a lot of them do it in a way that makes clickjacking pretty easy. So this is a screenshot from Bugzilla, which is issue tracking software that Mozilla use for Firefox. Also, WebKit uses it as well. This is what happens if it detects a cross-site request forgery attack. But actually what happens is we can click this button at the bottom to say, yes, go ahead, do these changes. So although it prevents cross-site request forgery, all that would be needed for a successful clickjacking attack is just to click on that button. So one of the problems with clickjacking, one of the things that makes it fairly tricky to carry out, is that we need to know the exact position on the page of the target. So you remember the Twitter example from earlier. In order to target this button and do the positioning, we need to know the exact number of pixels from the left and from the top in order to target it. But what happens if the page changes and the target moves? Well, if this is an attack that someone has prepared, if the page changes when the user actually does it, then they'll click on the wrong part of the page. So how can we get around this? One method which I've come up with is to use fragment positioning. Now I'll just go through this. People who are familiar with HTML, probably this will be familiar to them. So in the source of a page, we can have this anchor tag and give it a name. If we then visit a page and have this name at the end of the URL, the browser will scroll down to make that section visible. So we can use this same method to position a target in an iframe for a clickjacking attack without knowing exactly where it is on the page. Now, although lots of web pages don't use this a name tag, most web pages have elements with ID attributes, and we can also use ID attributes to scroll down to a particular element. So this is an example from the Google accounts page. Now, each of those little boxes you see is an element that has an ID. So we can use this method to target any of these elements without necessarily knowing where they are on the page. So although we're just used to seeing a browser scroll vertically to make a particular element visible, if we do this in a very small iframe, then the browser will scroll both horizontally and vertically to make the target visible. I'll just quickly show you how that works. So this is a page with some randomly moving buttons, and using normal positioning methods, we wouldn't know where to pixel positions of any of these elements. But if we load, if we include the ID of each of these elements in the URL, then the iframe will scroll to the correct one, like so. Okay. So everything I've shown you so far is pretty much what people know about clickjacking at the moment. Now, one of the problems, as I've said before, is that we're relying on cross-site request forgery to get data into a form and then use a click to submit it. But what if we can't use that method to get data into a form? How else can we get that data into the form just by using the clickjacking method? Well, one way is to use drag and drop. Now, every modern browser supports a drag and drop API. Drag and drop is similar to copy and paste. It lets you transfer data from one place to another. With drag and drop, you're using the mouse to do that. So you hold down the mouse button, move the mouse, and release it somewhere, and the data is dropped into a particular element. Now, the thing with drag and drop is it doesn't have the same origin policy that prevents JavaScript from accessing, it prevents JavaScript on one site from accessing content on another site. So the user can actually drag data from one site to another, and because user interaction is required, browsers don't prevent this. So here's just some code that shows how we can use the drag and drop API in a browser. So what it says is, when I start to drag this element, associate this data with it, some text, and when it's dropped, that text will be entered into a text field or onto the site. So I'll just show you that quickly. So this element uses the drag and drop API, and each time I drag it, it will associate some text with the element. This green area here is a page from another domain. And as you can see, each time I drag, it's putting different data into here. So this would be really useful if we can combine this with clickjacking and get the user to input data into a form. So how can we do this? First of all, we use the same hidden iframe technique that I showed you before. We have the little iframe following the mouse cursor. Secondly, we need to get the user to drag something. Now, there's many ways we can do this. It could be dragging a scroll bar. It could be some sort of game, like the sliding puzzle game I showed you earlier. Now, when the user starts to drag the particular element, we set some data with it. So this is the data the attacker wants to inject into the other side. Now, as they're starting to drag, the iframe will follow the mouse cursor. And then when the user releases the mouse button, the text will be entered into that field inside the iframe. Then we need another click to submit the form and the attack's complete. So I'm just going to show you this demo here, just to show you how that works. So this is a little game which people might be tempted to try out. So what we'll do is we'll start to drag this frog over here. Now you can see that little square that's appeared. That's actually an iframe. Actually, I'm just going to show you. Oops, that one there. I'll just show the page that's being targeted here. This is a generic social networking fake site. So we can send status updates like this, and so on. So we want to basically get the user to enter some text in here, click the update, and that will be sent to all their friends. So we're dragging. Now the iframe has got the text field on that other page under the cursor. So when we release the mouse button, the iframe is now positioned so it's over the update button. So when we click the on button, flat, and here is what's happened. That text has been injected there. So in this case, the iframe was visible, but in a real attack, it would be completely invisible. The user would have no idea what's going on. Okay, so that's text field injection. Obviously, downside to it compared to normal clickjacking is it actually needs the user to drag something. And that's a bit harder than just getting to click on stuff. Clicking is what most people do on the web most of the time. In order to get them to drag something around, we need to engage the user a bit more. So there'll be some more social engineering required there to carry out a successful attack. But on the other hand, it does completely bypass cross-site request forwardery. We're not relying on partial cross-site request forwardery to get data into a form and then get the user to click the button. We're doing everything just by using iframes and the user interaction. So there's many things this could be used for. For example, with webmail, you could target the to field, the body field, and then you could send fake emails from your user's account. You could also edit documents in some sort of authenticated document editing system and place data in there without the user realizing it. This technique works in all the browsers. It's completely cross-browser. Okay, so that was content injection, and that bypasses cross-site request forwardery. But we can actually do even better than that. And we can get data out of an iframe. So how does that work? Well, we actually reverse the drag and drop technique that I showed you. Instead of dragging data into an iframe from the attacker site, we get the user to drag content out of an iframe and onto the attacker site. So again, with the drag and drop API, we can use the on-drop event to get any data that's dropped onto the page. So what kind of stuff could we drag out of a page? Well, links and images are draggable by default. and when it's dropped onto a page, they get converted into the equivalent